Welcome everybody. Today let us learn about decision trees. A decision tree is a supervised machine learning model. It is used for both classification and regression. Decision tree creates a model that will predict the value of target variable. This is done by learning simple decision rules from the data features. Let us see the advantages of decision trees. It is simple to understand and easy to interpret. It can be visualized as a two-dimensional figure. As it requires minimal data preparation, it is suitable for various data sets and it can handle both numerical as well as categorical data. So it is suitable for multi-output problems. It acts as a multi-tool for different types of problems. Let us see the disadvantages. Decision trees can lead to overfitting, creating overly complex models. Decision trees may be unstable, resulting in different trees with slight variation in the data. Ensemble methods like random forest improve the stability of decision trees. Overfitting can be mitigated by pruning. Pruning is the process of removing branches or nodes from trees. Overfitting can also be reduced by setting minimum samples at leaf nodes or limiting tree depth. Tree depth is the maximum number of nodes from the root node to any leaf node. A decision tree consists of root node, internal nodes, branches and leaf nodes. Root node is the topmost node representing the initial decision or feature test from which the tree branches out. Internal nodes represent feature or attribute tests used for data splitting. Branches emanate from nodes and represents the possible outcomes of the test. Leaf node contain the predicted class label or values and they are the endpoints of the tree where decisions or predictions are made. Parent and child node. A node that is divided into subnodes is known as a parent node. It represents a decision or condition. The subnodes emerging from a parent node are referred to as child nodes. They represent the potential outcomes or further decisions based on that condition. Let us see how a decision tree grows by the steps involved in the decision tree algorithm. First step is initializing the tree. Start with a root node with the entire dataset S. The next step is attribute selection. Identify the best attribute from the dataset using an attribute selection measure, which measures the effectiveness of attributes in classifying the outcomes. Create a decision tree node containing the selected attributes. This node represents a decision point in the tree. Then split the dataset into subsets based on the possible values of the selected attributes from the previous step. Recursively apply the decision tree algorithm to the subsets generated. Continue this process until reaching a stage where further classification is not possible, resulting in the creation of the leaf nodes. The leaf nodes represent the final classification or regression values in the decision tree. There are two important attribute selection measures used in decision tree algorithm. One is Gini impurity and the other is information gain. Let us see what is Gini impurity. Gini impurity measures the disorder of a dataset. A lower Gini impurity indicates a more homogeneous dataset, while a higher Gini impurity suggests greater diversity among the classes. Gini impurity for a dataset is given by the following equation. Gini of P is the Gini impurity for a dataset or node. Pi is the probability of an instance belonging to class I. The summation sigma is taken over all classes. Entropy is another measure used to quantify disorder or uncertainty in a dataset. It is similar to Gini impurity. A lower entropy indicates less uncertainty, while higher entropy means more uncertainty. It is given by the following equation, where entropy of P is the entropy for a dataset or node. Pi is the probability of an instance belonging to class I. The summation sigma is taken over all classes. The log is usually taken with base 2 to measure entropy in bits. Information gain is used to Select the best feature for splitting the data in a decision tree. It quantifies the reduction in entropy or Gini impurity due to splitting of the data on a specific feature. It indicates the effectiveness of a feature in reducing the uncertainty or impurity. Higher information gain values indicate more valuable features. Information gain is the difference between the entropy before splitting and the entropy after splitting. It is given by the following equation, where information gain of S, A is the information gain for the feature A on data set S at the parent node. Entropy of S is the entropy of the original data set. SV is the number of instances in subset SV, resulting from splitting the data set based on the feature A. S is the total number of instances in the original data set at the parent node. The summation sigma is taken over all subsets SV created by the splitting of data. In this video, we have seen the decision tree algorithm and how it grows by the selection of best attributes for splitting. Thank you. Thank you for your patient listening.